Hello everyone. Today we are going to discuss about the buzzword of today's time, which is retrieval augmented generation. RAG is very important concept in modern era and are a very essential component of enterprise level AI applications like internal organizational chatbot. In today's video, I'm going to explain the RAG in detail and in a very simple and intuitive manner. Before we dive into RAG, let's understand how LLMs work and what are the drawbacks of LLMs in the modern era. When you give a query to a large language model like Claude, OpenAI, ChatGPT, Gemini, it tries to find out the best possible answer and respond back to you. And you have seen that sometimes it generates awesome on-point answers, but sometimes, interestingly, it very confidently posts you wrong answers. That could happen because of hallucinations or stale knowledge. Now let's try to understand what hallucinations are. These LLMs are trained on massive datasets, open text, public information. Now, when you are asking a specific question to the LLM, it's like to find a needle in the haystack. So the surrounding context and so much information can confuse the LLM, which could ensure that the LLM hallucinates and gives you a wrong result. Inappropriate result also can come because of the stale knowledge. Now all these LLMs are trained on some data and there was a cutoff time because of which your response may not be up to date. And also the LLMs doesn't know what happened 5 minutes back. So it's a stale knowledge. Also, if you ask the LLM something about your private data or any organizational internal data, will it be able to answer? No, because the LLM doesn't have access to any private data. Next drawback is the context limit. What is context limit? Whenever you post a query to any LLM, there is a context window that counts how many tokens you are passing. Though the modern models are accepting quite a large number of tokens, but there is a limitation. You cannot post, let's say, 500 gigabytes of documents to ChatGPT or Claude and ask some questions from there. So that says that the context limit restricts your input to the LLMs. To tackle all this, RAG-based architecture became very popular. Before we move forward, I am Parnab Sengupta. I am a software engineer currently working in AI data and analytics space. I have worked with Fortune 500 companies and right now I am exploring this fast-moving AI wave with you. So if you want to learn AI in a simple and practical way, stay connected and subscribe to my channel. RAG is like open book exam for AI. Let's assume that there is a student who has given a book, an exam paper. Now, based on the exam questions, the student will apply its own intelligence and will find that what is the suitable section where he can get the answer, fetch the answer from that place and writes down the same. RAG is also similar to that, where it will first retrieve the information from its content store. I will explain all this in details, but just try to understand on a very simple high level view where it retrieves information from its content store, then it generates the answer. So the first step for any RAG based architecture is ingestion pipeline. What is this ingestion? Let's say that you have 500 PDFs or humongous amount of dataset. Now you need to ensure that this information are processed before even the AI or the LLM comes into the picture to answer your query. So the first phase is ingestion, where your documents are chunked in small bits. Now there could be different ways how you make the chunking process, but chunking ensures that all your information are chunked into small bits and pieces and then passed to the embedding model. Now what does this embedding model does? It takes this chunking and each chunk it converts into vector embeddings. These vector embeddings are nothing but mathematical representations of each chunks based on its similarity or based on its characteristics. Once these vector embeddings are created, these embeddings are stored in a vector database. So this vector database is actually holding all these embeddings. Now when user comes and posts a query, what happens? That query gets converted into query embeddings. So this is similar to a vector embedding where the user query is getting translated into a numeric representation. Now this data goes back to this vector database for a semantic search and a retrieval process gets started. So now based on this user query, it finds the similar embeddings from the vector database. Once it finds, based on the architecture, let's say you want to fetch top 5 or top 10 similar results. So based on that re-ranker process, it fetches you the similar results and then it push that into the context window with the user query. So what happened here? You have that user query embeddings and the suitable similar results into the context window. Here, what happens? In the context window, you are giving the LLM only the similar sort of information or similar sort of answers which could result to give the answer back to the user. Now, then LLM use its intelligence to generate the response only based on the retriever context or based on the chunks which you provided to the LLM, and then the user gets its final answer. So the RAG-based systems are solving one problem, which is hallucination, massively, because now the LLM doesn't need to look for its knowledge base to answer the user, but whereas it is just giving the answers from the top ranked chunks which we retrieved for the LLM to find the answer from. Also, as long as your database or as long as your data is up to date, it's absolutely fine because you have already processed that data before this retrieval process. You can also work with private data and there is no concern with the context limits because you already have processed all your data. There are some key components which you need to factor before you design any RAG-based AI application. Your chunking strategy needs to be top-notch or based on your requirement, because it's very much possible that you are going to lose some context because of your chunking strategy. Let's assume that you are watching a movie and you're watching it from the midway or from scene 10. So you don't know, right, what happened in scene 1 to 9. So you lose that context. Similarly, your embedding quality, retrieval quality is going to be very strong. It has to be very strong so that your generated output to the user becomes a quality output. While you are designing the entire RAG-based system, you need to also evaluate your architecture very properly and application. Also, you need to ensure that it has a balance among speed, budget, and access control. With all this, if you consider different strategies of RAG are possible, like self-RAG, agentic RAG, that we can cover in a separate session. But this RAG-based architecture will ensure that how much capable your AI application is. Though RAG is a very important and crucial concept in modern AI era, but there are some limitations of RAG. If your retrieval is bad, then your answer generation will also be bad. You also need to ensure that you are ingesting proper data to the system, which is a major challenge in modern world, the data quality. So if your ingested data is not of good quality, then your application output will also be very bad. It causes extra latency compared to standard LLMs because it processes a lot more than standard LLMs while giving you an output. You also need to maintain your systems because now it's not only the LLM, whereas you are introducing a vector database, you are introducing chunking, retrieval, all these processes, vector embeddings, embedding models, and your ranking strategy. So you need to ensure that your maintenance cost is also under the hood. Now there is also one more advanced concept which has popped up, which is vectorless RAG. With the name, you can understand that we are offloading a major chunk of the RAG architecture. You need to understand that RAG is not a tool, it's an architecture. So you can design it based on your need, based on the system's need, or based on the product. Vectorless RAG overcomes the limitations of a standard RAG. If you want me to cover vectorless RAG, please comment on the video section vector and I will make a separate video on vectorless RAG. That's today's topic. I hope you have enjoyed the video. If you have done so, please do like, share and subscribe. It will motivate me to make more such video on AI related topics to keep you up to date with the AI progression.